This is a very interesting one. Temperature sensor has been sitting in an ice bath for a long time. So here is your temperature sensor, basically sitting in an ice bath for a long time. It is taken out of ice bath at T equals to 0. When T equals to 0, it is taken out of the ice bath and exposed to ambient temperature, which is 20 degrees centigrade. Sensor responds to step changes in temperature like a first order system with a time constant of 1 second. So time constant, which is tau, is given, which is 1 second. You expect, being in the ice bath and now exposed to 20 degrees centigrade, the temperature is going to increase and eventually it gets up to maybe 20 degrees centigrade, but it's going to take time. It's going to happen over a period of time. The relationship between sensor and output voltage is linear. And right at the bottom, here there is a graph given over here which tells you that, for example, because there's a linear relationship between the VTS, which is the output voltage, and the temperature, and it says at 50 degrees centigrades, that corresponds to 500 millivolt of output voltage, right? So the very first thing we need to do, since we need to find out the V naught at T equals to 1 second, we are going to imply this equation right here, and this would allow us to find out the temperature. What is going to be the temperature that this sensor system is going to sense after 1 second, at 1 second? And we use this equation right here. So again, this output voltage, which is going to be VTS, equals to 1 minus e to the power negative t over tau times T ambient. Now there are a lot of stuff, actually most of the stuff is given. So 1 minus e to the power. Well, t is going to be 1 second because we are looking at 1 second here, correct? So -1 here, tau time constant is given 1 second. So that makes 1. And the ambient temperature is given 20 degrees centigrade, right? 20 degrees centigrade over here. So I do 20 degrees centigrade here. And if I do the math here, I basically get VTS at 1 second. That would equal 12.64 degrees centigrade. If I do the math here, 1 minus e to the power -1 times 20, that gives me 12.64 degrees centigrade. Now I know from this graph that 50 degrees centigrade corresponds to 500 millivolt. Remember, this is in millivolt right here. So 50 degrees centigrade corresponds to 500 millivolt, which means 12.64 degrees centigrade would correspond to 500 millivolt times 12.64 degrees centigrade divided by 50 degrees centigrade. Centigrade will cancel out. And if I do the math over here, this basically corresponds to 126 millivolt. In other words, 12.64 degrees centigrade corresponds to 126 millivolts. Remember, this comes from the relationship that exists between the output voltage and the temperature, which is a linear one. This was given in the problem, correct? Now notice over here, let's focus on this circuit. This part over here is the temperature sensor, okay? So the temperature readings are then fed into this op-amp, which is basically a buffer. Whatever the voltage is going to be over here, same voltage is going to appear over here at this output. And then the two op-amps right next to each other here, these are the inverting amplifier with a gain of some value. And we know from the previous problem, for the inverting amplifier, the gain is equals to negative RF over RS, right? Negative RF over RS. I'm just going to simply ignore this negative sign because it just really means a phase shift and we really don't need to worry about it. And if I look at it, for this op-amp, for this amplifier, feedback resistor is 20K, source resistance is 10K. So 20K divided by 10K, that gives me 20 divided by 10, 20K divided by 10K. That gives you a gain of 2 here, correct? Similarly, if you look at here, you have the feedback resistance of 50K, source resistance of 10K. So 50K divided by 10K, that gives you a gain of 5. So the voltage that you get over here gets amplified 2 times, and then this voltage is fed into another inverting amplifier, which is then amplified 5 times, correct? Okay, what is this voltage right here? Well, we just figured out that voltage is 126 millivolt. And all I need to do is to take this number right here and then amplify it 2 times first and then 5 times first, because the two are arranged in cascaded series, correct? 2 times 5. And if I do the math here, 126 millivolt times 2 times 5, I basically get 1260 millivolts, which can also be written as 1.26 volts. So the output voltage at t equals to 1 second is actually 1.26 volts, and that is your answer.